Hi there, this is Math 8, Unit 1, Lesson 8, looking at rotation patterns. Today we're going to be looking at some shapes, and we're going to be moving them around different points to rotate them, whether it be clockwise or counterclockwise, a variety of degrees here. And so first of all, what I want you to do, what you did in class, is you took a shape like this one, ABC, this triangle here. And what you initially did is it said to rotate this triangle, ABC, 90 degrees clockwise around B. And to do that, perhaps you use some tracing paper here and you put a pencil on point B and you simply rotated that 90 degrees until it snapped in place and looked something like this. And so you would have traced that on your paper. You would have maybe put a little mark down here to know where that other point would have been, and you could have drawn and connect your dots here and here, and then it wanted you to then do the same rotation again for 180, and you would have had something about here, again something like this, and you would have had a shape like such here and here, and then it wanted you to rotate it 270 degrees, so you end up making a full square. So that was your initial part, which is taking this triangle and rotating it around, whether it be 270 or 180 degrees, to see what kind of shapes you could create by just rotating one shape around in a variety of ways. And so when you rotate around, you get different things. If I took a segment, which was the second thing you did today, you then took that segment and you also then made it rotate around a bit as well. So perhaps you started with a point we'll have here, we'll make it a little pink there, CG, and C to D, and you had a middle point there. And it asks you to play with that shape a little bit there. So number one said rotate the segment CD 180 degrees around point D. Well, 180 degrees is a straight line. So when you did that, you put a point down, and when you rotate it around, you rotate it until it kind of snaps in place, and you end up with a straight line going from one point to the other. So in this case here, this line segment would end up right about here. And if I was to draw that nicely with a ruler and connect my dots, I would have something about here for that line segment. That's the first one, right? Then it said rotate segment CD 180 degrees around point E. So with that one, the idea was, now instead of rotating around D, I put a pin mark right here at E, and I rotate it around, and we can see it creates nearly the same line. And these lines are actually going to be parallel lines, aren't they? They're going the same direction. And so this line ends up being right here at this point, and gotta move that there, right spot, and here at this point. And when we connect those dots, we can see that we end up with two parallel lines when we rotate around a center point E. Center point E. All right, and so these two lines are actually parallel to one another because we rotated around that point. Notice we said before, these are going to be equal distance from each other as well. It's an important concept for later on, that they're the same distance from one another, and so it allows me to spin things and create some parallel lines. For number 3, it said rotate segment CD 180 degrees around the midpoint G. So the midpoint of the line is the one right in the middle of it, which they happen already labeled for us, G. And when we did that, we recognized that when you rotate it 180, you end up with the same line. There's no change. Ends up being the same line and the same shape, nothing happening there. It's the same exact spot when you rotate around the midpoint. There's no difference. So whenever you rotate a segment 180 degrees, you end up with a line going in the same direction, or you end up with a set of parallel lines if you rotate around another midpoint. But that's essentially what happens when you rotate around 180 degrees a line segment. Okay? So here it asks, is it possible to rotate one line segment to the other? If so, find the center of such rotation. And we mentioned that a few minutes ago, that the center rotation means if you take an endpoint like this one, and you find a point the same distance apart. So in this case, 1, 2, 3, and then going 1, 2, 3 this way, I could potentially rotate around that spot and have the same line drawn on a second spot being parallel. So what that means, I take this line, and let's just try it here real quick. Let's say I take this spot, this line right there. If I end up having a midpoint or a center point here, I can rotate 180 degrees and it snaps in place on the one right below it. So I'm there to there. So I'm just rotating it from one to the another by finding a midpoint right there. So I can rotate it so that this one lands on top of that one because there is a center of rotation located here. That center rotation is important if I'm going to be able to do that. If there's not a center rotation, it just won't work. And you can't pick any old spot and say, that'll work. It doesn't work that way. You sometimes have to do trial and error to find that center rotation to figure out whether it will work or not. Again, the key is being able to explain why and how that happens there. And then you moved on to this shape, which had several triangles. And this was a series of triangles moved around. It's the same triangle again and again and again. That was moved around in different places in order to create the square on the inside. So we had the triangle ABC like so. That was our triangle there. The first question you did in class said describe a rigid transformation that takes ABC to CDE. CDE is over here. So that transformation to move this guy over to this place is what it's talking about. How do I go from one to the other? And so to describe that, there are a variety of ways of describing that. Perhaps what you did is you took point B and then you did a translation where you moved point B all the way over to point D, like so, okay? And once you had B on top of D, you could do a 90-degree rotation with D as a center and end up with triangle CDE. That could work just fine. Are there other ways? Sure, there are plenty of other ways you could do that. You could have rotated it first of all 90 degrees, whoop, and then done a translation B to D. That works just as well. The second one says describe a rigid transformation that takes ABC to EFG. EFG is the one down here in this space, so we're going to try to move this whole thing from there down to there. Again, similar idea. I could go ahead and if I wanted to, I could translate B all the way to F to start with. That would move the whole thing to there. And then I could rotate not 90 degrees, but keep going, 180 degrees to be in that same position. Order doesn't really matter too much. I could have done the rotation first. I could have done several things. I could have translated B to H for that matter. I could have done B to H and then done a rotation 180 and then to an H to F. It's kind of matters. What matters is what do you see first? How do you want to get there? So just being able to take that picture and trace it and draw it and move it could help you quite a bit. Describe a rigid transformation that takes ABC to GHA. So going from here to there. Again, same idea. I might take this shape. I could initially translate B to point H down here and then maybe rotate it counterclockwise 90 degrees to end up with it snapping on top of that one right there. Sorry, I gotta move my paper a little bit. So moving from here, translating to H, rotating 90 degrees around H, you end up with it lining up there. So that's a variety of ways you could get those ones. And again, you did that in class, and I wanted to know finally, do the segments AC, CE, EG, are they all the same length? And we would say, yes, they are. And the reason they are the same length is because it's that same hypotenuse of the triangle. We're just moving this shape around and around and around. Okay, so the summary today is that you can apply a 180-degree rotation of a line segment and you end up with different things. It could be mapping on itself if it's the midpoint. You could have an overlap, or you could have not an overlap, but just something that ends up being the same length. Okay, so there's lots of ways you can rotate things, 180 degrees, variety of things. Let's look at our homework then. It says, first of all, you have this shape, and it says the rotates segment CD 180 degrees around point D. All right, so that means we're going to take our shape, CD, here is C, and I map that around, make a little model, D. I'm going to rotate 180 degrees, so if I rotate it this way, I'm going to snap in place about there, and so I put my dot right about there, and then I can use my ruler to connect my dots. It's good to get a straight edge out if you can, just to make it a little nicer for your teacher. They appreciate that tremendously. Mine's not perfect, but it gets you an idea. So that's A, making that same long line. If I want to rotate that 180 degrees around point E, right, I can, oops, I gotta get my paper in a better place. Let's move it this way. Here we go. I could just twist it, and here's E. So when I rotate this around E, 180, I look to see am I parallel with the other one. I should be. And now I can come back and put those points down. It's always a little bit tricky. If you poke through, you can get a dot. And if I poke through, and I can get a dot. And then I should be able to connect my dots. Connect my dots right here for the rotation around point E, that midpoint, so to speak. So I put two parallel lines. Not perfect, but it's close. And if I rotate it around point M, we know that that is the midpoint of that line. And when I rotate that one, I end up with the same exact line right on top of it, right? So it just snaps right on top of that for that same shape, okay? So that's A, B, and C. Number 2, it says here's an isosceles right triangle. Draw these 3 rotations of triangle ABC together. Triangle ABC together. So first of all, what I'm going to do is just outline my shape down below so it shows through my paper a little bit better. ABC. ABC. Okay. And we're going to rotate the triangle 90 degrees clockwise around point A. So if I'm point A here, okay, this is a way to think about 90 degrees is I have a line right there and I have my 90 degrees about there, and so I need that to spin like in the shape of a T until I get the next T. So it would be about there is the idea. But I am doing my whole shape. So there's a triangle, A, B, C. And when I spin around point A 90 degrees, I end up with a shape right about there. And I put that little grid line just so I knew about where that would be. So I can fold the paper up and put a dot. Fold the paper up and put a dot about there. Then I could play connect the dots for the first shape. Got it. Rotate triangle ABC 180 degrees around A. So now we're going to take it here. I have my same little lines, my T that I made. And I'm going to rotate it 180. So I'm going to spin it until it snaps in place. I end up with a shape right here. So I'll put my dot here and a dot about here and play again, connect the dots there and there and there. And to do 270, right, we've already gone 90, so 90 is 1 bit, 90 is this far, 180 is this far, and 270 is one more turn. We end up here. And so in this case, draw my little line, draw my dots at point here and point here. And so we end up with a straight line there, a straight line there, and a straight line there, and I have a nice little windmill type of shape. Okay, looking at number 3. Number 3, it says we have 2 polygons, A, B, C, D, and A prime, B prime, C prime, D prime. Describe the sequence to go from one to the other. So let's take a look here, sequencing things together to make this work. So how do you get from this shape over to that shape is the question for the first one. And I'm going to draw this out a little darker so we can see through here. So here's A, B, C, D polygon, looks like this. And we want to get that on top of this one right there. One of the first things I notice is I do notice that D to D prime is going down 1 unit, right? So I'm definitely going to translate down 1, that's for sure. But when I look here, we can see that this looks like the image or the mirror image of that shape there. So it looks like perhaps we have a reflection going on. So I'm going to go ahead and trace this real quick just to double check. I trace my image, and I've already said that I want to translate it down 1, and when I translate that down 1, if I was to reflect over the y-axis, which is right here, that means to fold it over. If I fold this over the y-axis, do I end up with that mirrored copy on top of it? Yep, I sure do. And so it snaps into place. So for the first one, to go from here to here, I can translate down 1 and then reflect over the y-axis. That would work out just fine. Or you could reflect first, if you chose to do that. You could reflect first and then translate down 1. Up to you. For letter choice B, a little different shape here. All right, we have A to D, D to C. Here's A to B here, and B to C there. All right, that's my shape that I have that I'm starting with. I need to get this shape, though, over to here. So A is going to rotate quite a bit. We're going from kind of the bottom left to the top, aren't I? So there's going to be a rotation of some sort to make that happen. I'm also going to be moving things around quite a bit, aren't I? So this first thing, I got to think about, how am I going to get over there? Well, I could think about translating it over to the right, if I chose to do that, all the way over to here. Okay, that gets me to that place, at least from there to there. And then there's a rotation that around point A that's going to make this go the same direction. Now, how far is that rotation to make it go there? That I'm going to have to figure out a little bit, right? I have to figure that one out. So there's going to be a rotation, and there's also going to be a translation to get from one space to the next. Different ways of thinking about there. All right. So let's take this. Let's pretend we do our rotation first of all. Okay. Let's do rotation first of all. I do have some lines here on the grid lines. Right. So here are my grid lines. I'm going to go ahead and rotate around A, and to do that, I'm going to make a grid line here and here. I'm going to make a little T. This helps me know what a 90 degree is going to look like. Okay. So if that's where I'm at 90 degrees, and I line this shape on top of this one here, I see that I still have my T, don't I? Because I still have my T, I can recognize that whatever I end up doing, I'm going to rotate this shape, it looks like 90 degrees. Because if I take that and I slide it over and down, here I am right there. So my first thing could be to rotate 90 degrees clockwise. Once I've rotated 90 degrees clockwise, now I can translate, and I can translate over 1, 2, 3, 4, 5, 6, 7, 8. So I can go to the right 8, and then I can go up. So let's move over right 8, whoop, 8, and then I can go up 1, 2, 3. Right? So we're going to do a rotate 90 degrees clockwise. That's what we're going to do here. Let's double check it. Rotate 90 degrees clockwise. Translate right 8, puts me on the 4s, and then up 3, 1, 2, 3, and we're in business. So it took a few things to do, it took 3 steps to make that happen, but that is a rigid transformation to go from one to the other. Finally, for number 4, Lynn says she can map A, B, C, D, this one here, A onto B, just using reflections. So the question is, do you agree or do you disagree with what she is saying? All right, so it has to be a reflection. Now, one of the things you might first think is you might think, oh, well, yeah, we just flip it over, flip it across. But let's just double check what happens when you do that. If I take this shape and I sketch it here, if I was to reflect on maybe this line right there, let's pretend I could do that, all right? If you folded your paper over on that line, you do run into a little bit of a snag. Because when I fold that over on that line, notice it doesn't quite line up, does it? It's not going to work because the sides are different there. They're different lengths. Notice here that this length is 1, 2 on the line, and this length is 1, 2. Those are the ones that have to match with each other for this to work. So what's going to have to happen is you could actually play with this a little bit and see, well, what if I reflect it first of all, and let's make this dark. I make this guy darker now. I'm going to go not pencil but with ink. If I take this polygon and I reflect it first of all over the Y line, like so, notice that by doing that, one of the things you have is I can have my sides that match, right? We said before that this line right here matches that line right there, right? They match each other. So by folding over on the y-axis, or the y line, the vertical line, or reflection right there, my little lines my sides are lining up. Now I could reflect over this one right here, over the x, and by reflecting over the x, I do end up right on top of it. So doing 2 reflections, one over a y point or a y-axis line, and then another over an x line, I can end up with that image with 2 reflections, no rotations, good to go. So kind of neat to look at, it's kind of fun to visually see that. Hope that helps you out with your homework.